Okay, so this is my final project for CS437. So the problem that this project is solving is the fact that my work computer, which you can see here, does not allow me to input a USB device or get the proper drivers in order to utilize something like a digitizer. So a digitizer, if you don't know, is just like a tablet that you can take handwritten notes on. So I like to take handwritten notes, and so this solution here is a Raspberry Pi with the camera mounted to my desk, pointing down at my notes. So if you can imagine a sample workflow might look something like this. I'm in a meeting and I take these notes, which you can see here, and then I want to digitize them and convert them into a format that I can look at and work with on my work computer itself. So you can see all I'd have to do is SSH here into my Pi. So this is a PowerShell window, and then I'm just going to run Python 3 main.py. So when I run this is like the main driver code. You can see the camera is getting accessed. An image has been saved locally in my Raspberry Pi. It's going to output some of the words that it sees in the using Google Cloud Vision, the API. And then you can see the final line here is illinois.jpg and text file have been uploaded / updated to and then my repository and the location. So that's what outputs, and this is using a GitHub API and a key that I created. So what I'm going to do now is simply open. This is my personal repository. So if I wanted to view my notes, I'd refresh this page and I would go specifically into the notes tab. You can see I have some other sample ones that I've created, but what I'm interested in is this Illinois note. So you can see that the note that gets submitted, it takes whatever is in the upper left-hand most corner. So whatever the upper leftmost piece of text is, that's what it's going to take is the title, and it saves 3 files. The first is going to be like the raw output, so you can see that's the note that I showed you. The next is going to be like a scaled and pre-processed version of it. You can see this issue down here is simply due to the image not getting enough light. So I'm very careful to not give it too much light. It turns out that the best and most consistent way of light is actually my iPhone camera. So that's what I utilize to get a good output, but since I'm recording this video, I'm unable to utilize that iPhone light. So if you could imagine in a real sample output, this whole screen will get enough light and the output would not have this thing. It's lucky that there's nothing written down there in that bottom left corner, so we don't really notice. So anyway, that is the scaled, rotated, and pre-processed version of the image, and then the final file is this .txt file, which is simply what Google Cloud Vision API actually determines to be all the handwritten words that are in the image. So you can see our title, and then I just wrote 1, 2, 3, 4, 5, 6, 7, 8 in there. And so yeah, that's the output. There's going to be some stuff like this. You can see 9 was like grabbed with a bunch of other stuff. This is pretty normal, especially given the fact that in many of my notes, I'm not writing just in a line. I'm writing kind of all over the place. And what's really important is if I mention a specific topic and I want to go back and search through it, I'll be using these TXT files. So it doesn't really matter to me if it's getting it in the correct order. What's most important is that it's recognizing it in the first place. So it managed to get every number and then even including 9. So if I wanted to find the topic 9, for example, I'd be able to find it. It just happens to be attached to this big blurb. So that's that in terms of a workflow. If I wanted to make an update to this specific note, I would just rewrite on the paper and then run my command again through the command prompt because I built into the code that it will automatically update it if the title is the same, and it won't create a new file. So that's what that would look like. Now I'll get into some of the code that runs this. So I will start with actually the main.py file because that's the driver code. So I'll sort of explain some of the functions that are in here, and then at the end we'll get into how those specific functions look. So what we start with is get rid of that. What we start with is the original image. So we run this grab photo function, which actually comes from the photo.py file, which I'll show later. And then we scale that image using the scale.py file, which again, I'll show later. So after these two steps, we have a image that's been taken using the Raspberry Pi, and then it's been cropped and rotated. So it's now sort of in a position, and actually within the scale function, my pre-processing function is called, which is in process.py, which is why you don't see it here. It's actually called within that scale function. So after these two steps, we have a photo that's been taken, that's been rotated, pre-processed for OCR, and cropped. So that's what that output photo sort of looks like at this point that I showed before. So with that, we take, then this would be your GitHub repository key. So I don't share it here, but, and then you outline a repository name. There's some issues with a slash being in the path with GitHub when it takes it. So we have to do some stuff to remove that slash, but we still want to keep that path. So that's what's done there. And then the next thing that's done is we call the Google Cloud Vision API, which is like a really good OCR handwriting model. It's better than anything that I could find get running natively on the Pi. So I sort of outsourced that to Google. And what you see here is that we pull two things from that specifically. We pull words and we pull the title. So I'll show this get words function later, but that's what that's doing. And then you saw in the terminal, I printed the words and the title. So that's why you saw that. Next, we extract the name and the extension. So this is just working with the file name in the words. In order to get what we're going to call it in GitHub, we do some stuff with paths, create a commit message, do our authentication, and then essentially the outcome here is that, it's going to commit that file. So I've got some other stuff here in terms of upload or update, and it's going to check if the file already exists. And if it doesn't, then we create a new one. If so, then we simply just upload a newer version. So that's the main function. That's not where a lot of the actual code is. That's sort of just a driver that pulls in what our other things are doing. So now I'll get into those four other things now. The first of which is photo.py. This is very simple. It's just grabbing a photo and saving it locally to the Raspberry Pi. I had to use this like sub-process thing. So taking a photo using, I think it's just like using the terminal in the operating system itself rather than some sort of library. I was getting issues with like multi-threading and memory usage. I don't really know what was going on, but I found that this works. So this is what I used. And so that grabs a photo for my device. The next thing that would happen would be, I believe, this scale.py thing. So what's occurring here is, let me just double check that. Yeah, so what's going on here is that we're essentially taking the photo and using that green box that I showed in the video to get a bounding box, and then crop the image so that we don't have a bunch of space on either side or you can't see pieces of my desk. So that's what's happening there. We then rotate the image, and you see here, actually it's just one line in this, but we pre-process the image for OCR, and that's in the process.py file, which I'll show. But at the end of this, running the scale function, we have a, like I said, cropped, pre-processed, and then rotated image that can be sent to the Google Cloud Vision API. I'll quickly show what actually is in that process.py. So what's occurring here is doing some stuff that through some research I found was good for OCR. So some of this I had to play around a little bit with, considering the fact that, or considering my lighting situation, how thick my text is and stuff like that. So it's actually this sigma value that I had to play around with a little bit so that it would show up best and work really well with the model. But you can see through the comments some of this stuff that's occurring. I'm not super familiar with this, but through looking at other people's code and looking on the internet, this seemed like some of the stuff that you do. So Gaussian filter, enhancing contrast, reducing noise, applying a threshold to binarize the image. And then I preferred, I'm not sure if this is necessary, but I inverted the image so that the text appeared white and the background appeared black. So that's what happened there. At this point in my code, I have an image that's cropped, rotated, and pre-processed. The last thing to do here is to run the OCR model, which, like I said, I sort of outsourced to Google. So I imported Google Cloud here, and I imported their Google Cloud Vision, which, like I said, is a really good OCR model, it seems, for handwriting. So this is pretty simple, and I think this code is actually taken directly from Google itself, and I believe this is almost taken directly from Google, but I altered it slightly so that, again, we use that bounding box sort of code that I used previously to figure out what is in the most upper left, top left corner, and then we assign that as title, and we're going to return, first we'll return all of the text that we see in the image, and second title. So that's about it. The whole process takes, as you saw in the beginning, about 25 seconds to run. It would take probably a lot longer if I was running the OCR model on the Pi itself, but since it goes out to Google, it is actually really fast. So this is the whole process. I'll probably be utilizing this on a daily or semi-daily basis, just at least to convert my notes into a digital format, because right now stuff sort of gets lost in my notebook. So I'm really happy with how this project turned out, and thank you for watching my video.